Now, there is a limitation in some of the interface, like when it do the transmission, it cannot receive. But not all devices. You know, some devices, some older devices, they have some limitation. Like while sending, they cannot receive. While receiving, they cannot send. Which means they are a half duplex device. They're half duplex.
Okay.
But nowadays, all devices I see full duplex. But if you're connecting old device and the new device, if the older device is half duplex and if your new device is full duplex, then you need to go and change full to half. You need to switch from full to half, so that both can be in sync. Both can understand each other. Otherwise, the other guy will. Otherwise, what will happen is if one is half duplex and the other one is full duplex, full duplex will send and receive at the same time, but this guy is not ready to receive when he is sending. It will be a problem. So we need to change the duplex. The command is very simple. You need to go to the interface and say IPOSPF. Sorry. You need to say duplex full or duplex half. There is also something called duplex auto. When you put duplex auto, they negotiate and they adjust according to the neighbor. That's automatic.
Okay.
Now, if I go to the interface, let's say show IP interface brief, I got interface like fast Ethernet. I'll go to this first interface. Then config T, and then interface, and you will see duplex. You see? And there are three commands: half duplex, full duplex, auto. So leave it auto. That's good. Both the side, if they are full, they will go to full. If one side is half, the other one will automatically switch to half. Yeah, leave it auto. That's good. Okay, so that's about the duplex. Every interface has got bandwidth. Depending on the bandwidth, the speed will vary, isn't it? More bandwidth, more speed. If the road is broad, everyone goes fast. So every interface will have some speed. For example, fast Ethernet is 100 meg speed. Gig Ethernet is 1000 meg speed. But if you want to reduce, you can reduce. This is the command, just one command, speed. So, you know, you can, it is actually 100 meg for fast Ethernet. You can also bring down to 10 if you want. Because, you know, the other side, other router may not have fast Ethernet. They may be running old Ethernet. Ethernet is only 10 meg. Ethernet is 10 meg, fast Ethernet is 100 meg. So to match with the other neighbor, you may need to bring down the speed. But you can also say auto. Auto is better for both duplex and speed.
Okay.
So depending on what both can do, they will adjust. For example, I have another router with gig Ethernet. Now, this cannot support 1000. This is fast Ethernet, right? I choose fast Ethernet 00. This cannot support 1000. So what will happen is the other router will bring down the speed to 100 when you say auto. Right now.
Okay.
Very important topic next we are entering, which is OSPF. Sorry, OSI.
Mm-hmm.
Open System
OFI.
Interconnect. You know why it is called as Open System Interconnect? This is a set of instructions which is given to the device to follow when the device generates traffic. I repeat. See, this is my own definition. Okay, so OSI is set of instruction given to all network participating device It can be from Cisco or Juniper or whatever in the world. If the device participates in network, this instruction will be same. This instruction is given to the device operating system to follow while they generate traffic. It's the instruction, it's the rule, it's the steps that needs to be followed. Why? Why should I follow this instruction? Only when you follow this instruction, all the system will be open to connect. Open means they're ready to understand each other, ready to talk to each other.
Like they can.
That's the meaning of open. Open.
Okay.
See, if I be stubborn, saying I will talk only in my mother tongue, will I be able to teach the other country people? Not possible. When I switch to English, I'm open to all. Likewise, we have various type of devices. Someone have got iPad, someone have got cell phone, someone have got laptop, computer, PCs, printers, scanners, fax machine, what are the servers, routers, switches. They all want to communicate. And some are from Cisco, some are from Dell, some are from Lenovo, some are from Toshiba, some are from Apple. But regardless of all these variation, they are still communicating, isn't it? It is because they are all open to communicate because they have followed one rule called OSI. When they all generate traffic, they all followed one common rule, common instructions. They have followed common instructions. So when a Dell laptop send a mail, a HP laptop can receive a mail same as I send. Same as we send from Dell. HP is not going to change the matter in the email. When you send email from Dell, the HP computer, when it receives the same mail. There is no change in the mail. It is because both standard are same. HP, Dell, they all followed same standard, same instruction, same standard in developing the packet. So it's the reference model, OSI, Open System Interconnect. All the systems are open to interconnect each other. All the systems are open to interconnect each other because of this rule that are given, and every device follow. So Open System Interconnect is the very important rule that every network device should strictly refer. So it is also called as a reference model, OSI reference model. Now later, OSI reference model was modified as TCP IP model. OSI have got 7 layers. And TCP IP model has got only 4 layers. But basically it's the same function. How can 4 become 7 and 7 become 4? But the TCP model has got these 3 in 1. And these 2 in 1.
Correct.
Actually, these 2 are in the NIC card, network interface card, isn't it? If you take your laptop or any desktop, you have a NIC card. That NIC card only have got this MAC address. That NIC card only have got the program to a driver. We call it as network driver, isn't it? We install driver, network driver, the software. That is the software which is responsible for transmitting and receiving data. And those things are running on this 2 layer. Means NIC card has got this 2 layer. So with the NIC card only we access the network device, right? That's why they have named it as network access layer. They have simplified it. And network layer is the one with which we connect to different network. What is different network means? Internetwork. Communicating from one network to another network is internetworking, right? So the network layer, another name is internet layer. That's nothing wrong. Same meaning only. Transport layer is transport layer. And these 3 are taken care by the operating system. What is an operating system? It's nothing but an application. Operating system is nothing but a software, a big software that has got many other softwares. With that application, you are able to use the motherboard, you are able to use control the computer using the GUI.
Correct.
That's a kind of application. These 3 layers are not under your control or my control. They're automatic. See, someone can write an access list matching some port number and they can block some traffic, which is transport layer. Transport layer is responsible for port numbers. So you can do some changes here. You can do some changes here because you put IP address, subnet mask, all the blah blah. You know? So you work here, you work here. You even work on MAC address, MAC table, like MAC. There is a MAC access list. MAC ACL, we call it as MAC ACL. So based on the MAC address, also we can decide some. We can decide whether to allow or transmit. So these things are configurable. So they cannot be grouped. They need to be separate. But these 3 are taken care by the operating system. You have no control. So they have collapsed, they have clubbed it, they have joined it as one layer called application layer. Likewise, these 2, you cannot separate. If you take a NIC card, which is responsible for physical connectivity, that same NIC card only has got all this driver and the MAC address and all this stuff. So you cannot separate this. So that's why they are grouped as one. So if someone says OSI layer, TCP IP layer. Don't confuse. Both are same. Cannot be different. Some people used to teach this TCP IP model is as if it's a newer version. OSI is gone. Some people will tell OSI is gone. Funny. That's not correct. OSI explains things more granular. It explains every step individually. Even though these three functions are carried out by operating system, this is three functions. What is wrong in keeping it separate? Nothing wrong.
Yeah.
When you keep it separate, you understand better. Instead of keeping it together. So, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer is what? OSI. Now, the first three layer here called as application layer, transfer layer, internet layer instead of network, and then instead of data link layer and physical layer, here it is called as network access layer. Now, some people will say, hey, Microsoft only follows TCP IP model. Someone will say, what? Microsoft people only defined this. They only follow TCP IP model. No, not like that. Not like that. TCP IP model, they will talk as if, Microsoft people, TCP IP, network people, OSI. No. Nothing like that. All 7 layers are applicable in TCP IP model. But you don't need to call, you don't want to call separately application layer, presentation layer, and session layer. The reason is you don't do anything with this layer and this layer and this layer. They're all taken care by the operating system. That's why software people, they don't call 7 layer, they call 4 layer. They say TCP IP is the latest reference model. Basically same. Now, let us learn this OSI 7 model, 7 layers now. Let's learn the 7 layer. Or I would like to bring another one.
Yeah.
Keep like this. And then cut this off. So we got OSI reference model. The reason why I have 2 copies of it is we got 2 computers that wants to communicate.
Yeah.
And one in the left and one in the right. Sender, when they send, the traffic is actually generated starting from application layer. And it goes to physical layer. So this guy,
Yeah.
the sending computer A and receiving computer B. Between these two, the communication wants to go. If A is talking to B, the traffic is actually generated from an application, goes to presentation layer, takes some values from there, session layer, take values of session, transport network, data link layer, and the physical layer. So now what happens is, these things that are added to the data explains a lot of things to the network. You see, A is talking to B. See, I have eyes, you have eyes. If you're coming, my eyes will tell to my brain that you are coming. So immediately I will come, get up and come to the gate and I'll welcome you. But the computers don't have eyes. If A is sending teletraffic, how B knows that A is sending a traffic? First thing is how B knows that A is sending traffic. Secondly, how it knows
Yeah.
what traffic it is, and how it knows when it was sent, how it knows within what time I need to respond back. So all these things someone should tell while talking. While talking, A is sending all this information. This is just data. Data alone is not going to be. It is going with all these info. Only then B will understand how to handle this data. If you don't have the information about who should receive, then no one will receive. When to receive, it is nothing but time frame. If a packet goes very late to the receiver, better receiver should not process it because it's already late by this time. The timeout might have happened. So what I'm trying to say is sending data only is not our aim. Sending data and making the receiver to understand the data is very important. For that, there is a need for a preparation. That preparation is what we call it as OSI. Preparing the packet so that the receiver will understand how to deal with the packet. So, when you open an application like, Putty, have you used Putty? Yeah, we use for telnet,
Incoming packet. Yeah.
We use even for console, serial connection. That is an application. In that application, you punch in SSH.
Yeah.
Let me show you.
Yeah.
So when I click, you see, when I click here, SSH, and put port number 23, this application called Putty is telling that I'm trying to do SSH 22. When I put 22 and this is the destination IP, the packet will go to this IP saying I am expecting SSH session from you. So port number, everything put together, IP address, port, everything we put through one GUI, which is an application layer. Application layer is nothing but the medium through which you interact with the network.
Yeah.
The medium through which you interact with the network is an application layer.
One question. So in application we are accessing the port number, right?
No. Because of port number, no. Because of port number, I know I understood your question long back. Because of port number, you should not call it as transport layer.
Sir, one question. So here in application we are accessing the port number, right?
Here, so that it can decide.
That is sitting in transport.
So that this computer can decide what application layer protocol to choose to generate this traffic. See, port numbers are of transport layer, no doubt. But that port number needs to be informed to the application layer so that application layer will create a suitable environment, create a suitable application, give a suitable application for you to communicate. So telnet, it is a layer 7 protocol. Telnet is not layer 4 protocol.
Okay.
Because we put port numbers in the transport layer, you should not call all protocol SSH, FTP. Don't call them as transport layer protocol. They're all application layer protocol.
Okay.
It's layer 7. Because of port number, we should not say all major protocols are layer 4 protocol. No. Layer 4 is responsible for attaching the port number to the packet.
Application layer protocol, yeah.
Even though we are giving in application layer, but attachment is happening at
only transport layer, correct. So we need to inform the operating system, which is a part of application layer. We need to tell the operating system
even though we are giving
expecting,
in
so
application
that
layer, but
operating system will
attachment
decide,
is happening
okay,
at
for year
transport
23,
layer, right?
Mr. Transport layer will give you when you go there. Let me give you only the application. Operating system will provide the application. Actually, transport layer is also under control of whom? Operating system only. So when you pick putty, the necessary port numbers will be ready, and when you say 22, immediately application layer will inform transport layer to put 23. So 22 if you are doing SSH.
Yeah.
So the right application we select, and we inform the network, this is what we are trying to do. We are trying to SSH. We are trying to do FTP. Through application only we tell the network what we are exactly doing. Accordingly, transport layer will decide the port number. But the application is picked up in the application layer. Based on what you have picked in the application layer is what the port number is decided in the transport layer. They're all connected. Now, after the application layer, the presentation layer does the job of presentation, as the word says. The words, the name and all, they didn't simply give. If you understand this word, you will also know the meaning of this, function of this layer. Presentation layer, you see, presenting to the network. Your data is getting presented to the network. See, if you are talking to a child, you need to present it in such a way that child will understand.
Okay.
You may want to give water. But you cannot give water in a big glass, which you used to give me. Child won't know that you are giving water. For a child, you need to have a feeding bottle. Then it will smile at you. I know this bottle. I used to drink milk and water. So you need to use the right environment to make understand the network what you are trying to do.
Yeah.
For example, if you are using HTTP, what will be the environment? HTML. HTML is the presentation layer.
HTTP is the application protocol.
Correct.
Okay.
So HTML is what going to be picked up as the environment for HTTP to work. Right. So presentation is very important. The presentation
HTTP is the
layer,
application protocol, no?
HTTP, HTML as an example. But what I'm trying to say is, if you are sending a document in a .doc format, and if you send the same content using .pdf, how B knows that you are sending PDF? Same content. Inside both have got same content. But one you are sending as .doc, another you are sending as PDF. Who is doing this? Presentation layer do this. Because presentation layer is doing this marking, hey, this is a document. You need to open with Microsoft Word. And same content, when you are sending as a PDF, it is a presentation layer that is sending a hint to B saying, hey B, when you receive, handle it with Adobe Reader, because this is a PDF. You cannot open with Word, MS Word. The PDF cannot be opened with Word. So when the sender is sending a PDF, how receiver knows that I am receiving a PDF? I need to use the Adobe Reader, because presentation layer here has put a hint there. So to your data, the presentation layer is adding a hint saying this is a .pdf. And then session layer is setting a time frame. You see, a computer may parallelly do multitasking. Even right now, we are doing multitasking. My laptop is doing multitasking. One, it is remotely logging in to you. It is connecting to you. Second, it is sending signals every now and then so that we stay connected. Third, it is sharing my desktop with you and refreshing my desktop, resending the packets again, so that your screen will show this screen that I am sharing you. And also it is sharing the voice that I am talking now. Along with that, there are also some other local things that may be running in my laptop. Some mail is opened. So there are multiple tasks going on. Multiple tasks is using the internet. Maybe my Gmail is using the internet. My video is using the internet. My voice is using. All cannot use the internet at the same time. There should be some sequence. So how they are sequenced? By setting time frame. For example, 8 o'clock you go, 8:01 you don't go, you go. Now we keep sending different process so that all type of traffic will be able to use the network. So this all happens in very micro nanosecond differences. You will not be able to see. I will not be able to see. But truth is, not everyone is using the processor and the network at the same time. Every application uses different time period. That is why they are all going out without any conflict. Even though the picture that I'm sharing with you and my voice that I'm talking to you goes in different time period, they are in sync. For you, they are in sync. It is because they know the human ear delay acceptance. Human ears can accept a certain delay. So human ears will not know that it's a delay, but there is a delay, some microsecond delay. With that only, the packets are generated and sent. That is what the job of session layer. That is why it is called a session, which takes care of time, who is going to use at what time, so that two applications will not clash, conflict.
So session is not sitting in an application, right? For example,
No.
For example, Zoom chat, right? Zoom video conferencing.
Yeah.
Session layer won't be sitting in Zoom application, right?
No, Zoom application session is different. This session layer is different.
Session
See,
is
Zoom
not sitting in a
maintains clock.
application, right? For example, we have
Even
we have
every device.
for example, we have
even
this
if you
Zoom
ping,
chat, right?
there is a
Zoom
clock.
Zoom video
Within
conferencing.
30 seconds,
So
if you don't
session
get the
layer
reply,
won't be
you
sitting
can say
in
request time lock.
Zoom application, right?
For every traffic, there is going to be a time frame. That is the
Okay.
default session. But Zoom application session
Okay.
is applications session. That is not this session which we are talking. See, you might have started a meeting at 8 o'clock and you might have said 30-minute session. That is applications session. Application is guaranteeing you, the user, that 30 minutes only you can use the application. After that it will close. That's the business part of application. That is Zoom company's time clock session. That's not this session. This session is for every packet to tell when the packet should be processed and when it should go, within what time the response should come. So that if the response is not coming on time, it need not to wait holding the session. It can give the place for another one to use. Session cannot be kept opened. For example, the first week of this is the first week only. We are in first week. First week, now you go to any mall. People will have baskets of provision to bill in malls like Reliance and D-Mart. And you need to wait for your session to come. And now, the guy who is in the front of you, he said, please, wait. I'll go and collect one more material from third floor. Will he say yes? No. He is going to say, okay, sir, I am cancelling your bill. You need to come again from the beginning. Let me go to the next customer. He's not going to wait for this guy to go to the third floor to pick one item, come down. That too in the rush hours. Because the other customers will be in trouble. So for every customer, there is a period. This is what the maximum time you should take. Management will very clearly say, this is what a maximum time a customer should be with you. You need to somehow finish the billing, go to the next customer for billing. That is very important for everyone to get served properly. Likewise. There are various applications, like various customers, there are various applications using the network parallelly at the same time. But they cannot really use parallelly. Can all get billed parallelly? Not possible. Someone should be in queue. Yeah. So session layer will take care of it. Next. After session layer, transport layer. Transport layer, as the word says, transport. This is responsible for transportation. See, early days, when you send a letter through postal department, I remember we had a 15 paisa postcard. And there is another postcard 30 paisa. If you buy a 15 paisa postcard and send me a letter, you will not get an acknowledgement saying I received. But if you send a 30 paisa postcard and send me a letter, after I receive, there will be another attachment which this postal man will get signature from me and deliver to you saying he received it. See, this is the acknowledgement. So there are two type of transportation, two type of letter. What does the letter carry? Data, no? What do you write in the postal card? Data. Here also data only. So the postal department followed two types of transportation. One is reliable communication. Another one is best effort. You see, the first one, the postcard without acknowledgement, is best effort. We'll do our best. We'll go and deliver him. That's all. But the second one is reliable. After delivering, he is giving you the acknowledgement back. So here, transport layer decides what type of transport this particular traffic needs. If you are using telnet, then it is going to use reliable, which is TCP. If you are using some real-time protocol, RTP, in the application layer, voice, then it is going to pick UDP. So depending on what application layer protocol you picked, the transport layer port number will vary. If you are doing file transfer, it will take TCP. If it is DNS, it will use UDP. DNS is UDP 53.
So how it is deciding the file transfer is initiating?
No, you are using FTP application. You are using application, no? That application says it's an FTP. For FTP, it's predefined as TCP 2021. So if you are using any if you are using any voice related application, for example, if you are using voice related application,
so how it is deciding like
application, what you will open?
if a file
will
transfer
you open
is initiating
mailbox? No.
So it has
You will use some special application, no, to send a voice, like WhatsApp, call, something like that. That is the
okay.
Correct. Yes.
For example,
so depending on what application layer protocol you open, not only the port number is decided in transport layer, it also decides what protocol to follow. If it follows TCP, then it is going to be connection oriented, reliable.
So they will
acknowledgement.
They will open some TCP.
If it is going to pick UDP, then
it
is only best effort delivery.
Okay.
Now the next layer is network layer. This is the layer where the network is determined from network and to network. I am coming from 10.0.0.1. Where am I going? Am I going to same network? Okay, fine. Same network. If I'm going to a different network, then I need to send to router. So, because we know this address that you are seeing in this layer talks about what network the packet belongs to and to which network the packet wants to go, we call this as network layer. Nothing wrong in saying internet layer also. Both us. Sorry. Next is data link layer. This is the layer in which the immediate device informations are seen, like MAC address. Our MAC address and the neighbor MAC address is given to a packet by the data link layer. So that when B receives the packet, if B's MAC address matches with the destination MAC address of the packet, only then B will accept. So data link layer is the one which is going to provide source and destination MAC address for every packet. Now, when the port number is given and protocol is selected, the packets are called as segment. Why, the packets are going to be segmented here if the packet is too big. If the data is too big, According to the capacity of the cable, the data will be cut into pieces and sequence number will be given. We call that piece of data, not the complete data. It's a part of data, a segment. And when segment comes and gets the IP address, source and destination, we call it as packets. When the packet comes down and gets the source and destination MAC address, we call it as frame. And the frame is converted into bits and bytes and sent out of the physical layer, and the receiving device receives it and checks whether the MAC address matches, and if matches, it will remove the layer and it will forward it to the upstream network layer. Network layer will check whether the IP address matches. If matches, then it will go and send it to transport layer. Transport layer will look the port number. Is the port number allowed? If it is allowed, then it will go and tell the session layer. Session layer will check whether this traffic is coming on time or delayed. If it is coming on time, then it is valid. Then it sends to the presentation layer. Presentation layer see how to open this packet. Is it a PDF? Okay, if it is a PDF, then I'll tell the application layer to open with Adobe Reader, PDF Reader. And now you are seeing the data, same data what this guy has sent. So whatever is added here is getting removed here. So on the sending side, we call it as data encapsulation. On the receiving side, we call it as data decapsulation. Encapsulation happens on the sending side, receiving side decapsulation happens. On the sending side, it starts from application layer, goes down to physical layer. On the receiving side, starts from physical layer, goes to application layer. Now, which one is layer 1? It's always physical layer is layer 1. And this is layer 7. Even though the sender is starting from application layer, it cannot be called as layer 1. It is always layer 7. This is just a number given to identify the layer, not the flow. This number is not determining the flow. The number is simply to identify the layer. When I say layer 4, you understand it is transport layer. When I say layer 6, you understand I am talking about presentation layer. Just to name, just to map, instead of using the name transport, session, presentation, we use number. Layer 6 means session layer. Layer 5 means session layer. Layer 6 means presentation layer. All right, layer 2 means always data link layer. All right, in our next class, we will talk about TCP IP three-way handshake. We'll talk about TCP UDP differences in depth with TCP IP three-way handshake. All right. I'll stop here.
Okay. Sure. Okay.